All right, we're just going to do two sort of quick dimensional analysis and stoichiometry practice problems just so you can kind of see in practice how to use that figure that I was showing you. Also, if you just want to do your own thing, it's just more practice for you to do with dimensional analysis. So basically, I feel pretty comfortable just writing out, before you've even looked at the question, I feel pretty comfortable writing out everything that we just did. I'll actually use the, okay, so we'll have density, mass. I feel pretty comfortable literally writing that figure out, because if you really wanted to, you could just memorize it and write it on your exam. So this is something that you could, as long as you memorize it, you will have a noteboard that you could write it on, that you, if it makes it easier to do the math with, you don't need to necessarily try to do these questions without the figure if you're planning on memorizing it. But so let me go ahead and write out that whole figure that I just drew. I'm going to fast forward so you don't have to watch this. So now that we have it written out, just remember that, okay, so for example, notice in this question that I gave you properties about reactant A. I gave you something about this reactant right here. A density of 2 grams per liter, and it has a molar mass of 100 grams per mole. And notice that we have the volume of the solution is right here. We're obviously going to need that as well. So basically, we are starting off right here. But the question is asking for the concentration of B, which is a different property. It's a different language, essentially. So that means that's telling us that we can't just go solve for concentration. We can't just go from here to here, because that's going to give us the concentration of A. We don't want the concentration of A. We want the concentration of B. So what we're going to have to do is we're going to have to convert this density to moles, go through the stoic ratios, the expected ratio, like the one that we get from the reaction, with what we actually have, to convert that to moles of B, and then use the volume to convert moles of B to concentration. Right. So this is basically what our roadmap is going to look like here. Right. Convert density to moles. We're going to go through the stoic conversion. Then we're going to convert moles to concentration of B after that. So just to show you that, essentially, we're starting off with density. So the first thing that we need to do is convert density to mass. So we have a density of 2 grams per liter times a volume of 0.5 liters is going to give us a mass of 1 gram. So we have 1 gram. It has a molar mass of 100 grams per mole. So if we divide that molar mass by 100 grams per mole, we're going to be left with moles, which is 0.01 moles. Right, so now we have the number of moles of A. We are arrived here, and now we can get to, we need to use those stoichiometry ratios to get to moles of B. So we have our moles of A, that the theoretical from the reaction, I'll do this in orange, sorry, so you can track that we're doing stoichiometry here. The theoretical is that we have, from the reaction, every 2 moles of A is going to be reacting with every 1 mole of B. So now let's look at what we actually have. We actually have 0.01 moles of A, and we're trying to solve for X moles of B. And whenever you go through and do that cross multiplication, I'll give you a chance to pause it right here if you want to do that on your own. Basically, I just know that there's going to be twice as much mole A as there is B. So we're basically going to have 0.005 of mole B. Right, and I should have written that in red. Okay, so now we have the moles of B. We are right here, and so now notice that all we need to do to get the concentration is just divide it by volume. So we have 0.005. I'm going to write it in scientific notation because I'm anticipating that I'm going to have to do some ugly math with that. So 5 times 10 to the negative third moles of B divided by that volume. That is 5 times 10 to the negative first liters. that is going to give us 1 times 10 to the -3 minus -1, -3 plus 1 is going to give us -2 molar. That's our concentration, and that is our answer. Right, so basically, you can travel freely left and right as long as you're within the same species. If you need to convert a reactant to a product or one reactant to another product to figure out some other value, you have to go through the stoichiometric ratio. So this really shouldn't be that bad. We're going to do one more example problem with this. Let me get all of these writings that aren't in the figure off the screen. All right, so now notice in this practice problem, I was a little bit nice to you, and I actually gave you some answer choices. So I'm expecting a thank you letter on my desk by 8 a.m. Please, I'm not going to be awake at 8 a.m. Obviously, I know you're not going to send you a thank you letter for me making you do math. But 0% chance that whenever you're watching this that I'm going to be up at 8 a.m. the next morning. So they give us the reaction. So notice that the ratio is going to be 3 to 2. Right. So after the reaction, the concentration of product D, so they are giving us, this is what we're starting off with. Product D, notice that I don't even really care that it's a product. I just care that it's one species, which is why I'm keeping it green. Right. Product D is in a volume of 2 liters, and it has a concentration of 0.3. The molar mass of reactant C, so this is talking about C, this is a different thing. I'm going to basically mentally underline that in red, a different species, and we're looking for the mass of C. Right, so just kind of road mapping this out, look at what we started off with. We started off with concentration, so we're going to start here, but we need to answer the question about a different molecule. So we're going to have to go through that stoichiometric conversion. So we need to convert this to moles first. Then we're going to go through those stoichiometric ratios to convert it, the moles of D to moles of C, and then we're going to go back and convert that to mass pretty easily just by multiplying it by the molar mass. Right? It will be really straightforward and really easy. We'll do all of this pretty nice and easy. Okay, so let's start off by converting concentration to moles. So the way that we do that is we're going to multiply the concentration. So 0.3 molar concentration times 2 liter is going to give us a number of moles that is 0.6 moles. So that's how many moles of D we actually have. So now we need to run it through our stoichiometry. We need to run it through our stoichiometry, and that is going to give us wrong color. So in the reaction, we typically have 2 moles of D reacting with 3 moles of C. What we actually have is we actually have 0.6 moles of D, which if you go through and do your cross multiplication, you're going to have 0.9 moles of C. That's how many moles of C we're going to end up with, right? Basically, this ratio has to stay constant. So even though we only have 0.6 moles of D, that's only going to be able to interact with 0.9 moles of C. That's what that stoichiometric ratio is for. It's keeping that 2 to 3 constant regardless of how much we actually have. Okay, so now we can take this number and the 0.9 moles of C, and we just need to convert that to mass. So we just need to multiply that by the molar mass, which is 60 grams per mole. 6 times 9 is 54, so this is going to be 5.4. It should be 54. Sorry, I was doing scientific notation in my head. 54 grams should be the number that you get, and the answer choice is D. This will be one of those points where I'll point out that, like, notice that our answer choices were all pretty different numbers. And what that basically means, we talked about this a little bit in like using the answer choices to help you, is that if we had to do an SI prefix change somewhere in here or there was scientific notation, we actually could have ignored it. So even if we ended up getting 5,400 grams, the answer has to be 54. Just we'll point that out right there. There will be probably a few questions that's going to be handy, and I'll point it out in the mastery section, but I'm not worried about you from there. Right. Okay. So that is the dimensional analysis and stoichiometry section. Hopefully this figure helps, makes it a lot easier, and I've got some practice for you to do right after.